All right, so get ready. We're going deep on Copernicium today.
Oh, that's a fun one.
Yeah, I've been looking over all this stuff, Wikipedia, some articles on the history, and I got to say, I'm already hooked. I mean, this element,
Yeah.
it's completely synthetic.
Yeah.
So it's never found in nature. And then on top of that, it's like insanely radioactive.
It's true.
It's like the rock star of the elements,
Ah.
mysterious and maybe a little dangerous.
I like that. Yeah, it pushes the boundaries of what we know about chemistry for sure.
Okay, so before we get into like all the nitty gritty,
Sure.
can you give us like the Copernicium 101? Like, what is this thing?
Absolutely. So Copernicium,
Yep.
its symbol is Cn, and it has an atomic number of 112.
Okay.
So that means it has 112 protons in its nucleus, which puts it way down there on the periodic table with the heavyweights. It's in the D block, specifically group 12, and it's classified as a transactinide element.
Transactinide, okay. I mean, that already sounds intense. Is that because it's synthetic? Like, is that part of what makes it a transactinide?
That is part of it. So all of its known isotopes are radioactive.
Right.
And they decay incredibly quickly.
Wow.
The most stable one, Copernicium 285,
Okay.
has a half-life of about 30 seconds. So to put that in perspective, imagine trying to study something
Yeah.
that disappears faster than you can make a cup of coffee.
Oh, wow. Yeah, that's fleeting.
Yeah,
So, I mean, how do scientists even create something that doesn't exist naturally?
right.
This isn't like baking soda and vinegar, right? We're talking
No.
high-level stuff here.
No, it's we're talking about using a heavy ion accelerator,
Okay.
and it smashes atoms together at incredibly high speeds.
So it's like a microscopic demolition derby.
Yeah, but with a purpose.
Okay, I like that. All right, so which elements are we smashing?
Right.
What are they using to make Copernicium?
So in 1996, researchers at the GSI Helmholtz Center in Germany,
Okay.
they created Copernicium 277
Mm-hmm.
by colliding lead and zinc atoms.
Lead and zinc.
Yeah.
Really?
Yeah.
Huh. I would have thought, I don't know, something much more exotic.
Right.
Something rarer to make
Yeah.
something like Copernicium.
It's really more about the nuclear properties and how they interact during the collision
Okay.
than what the actual elements are. So you can take common elements, smash them together in the right way, and get brand new elements.
That's pretty cool. Okay, so they smash lead and zinc. Boom, Copernicium, end of story, right?
Well,
Or is there more to this?
the path to scientific discovery is rarely straightforward.
Oh,
Initially, there was some controversy because one of the scientists involved, Viktor Ninov,
yeah.
was found to have fabricated some of the data. It became a real scientific whodunit.
Hold on, wait. Fabricated data. That's like a cardinal sin in science.
It's a big no-no, yeah.
So how did Copernicium get its official, stamp of approval after that?
Right. So that's where the importance of independent confirmation comes in. Another team, this time at Riken in Japan,
All right.
they replicated the experiment
Okay.
and confirmed that Copernicium was real. They validated the original findings minus the, fabricated data.
Right.
So it was a huge relief for the scientific community.
Yeah, we bet.
And eventually, IUPAC, which is kind of the governing body for chemistry, officially recognized Copernicium as an element in 2009.
2009. So that's over a decade from like first creation
That's right.
to actually being like, okay, this is legit.
Yep.
That's a long time.
Science moves carefully.
Yeah, it does. It does. Okay, so we know it exists, but what do we actually know?
Right. So that's the tricky part.
Yeah.
It's so short-lived
Right.
that studying its properties is a little like trying to watch a firework that vanishes in a blink.
Yeah.
But scientists have made some predictions.
Ooh, predictions. I like predictions. What are they thinking? What are they saying about this element?
So based on its position on the periodic table and a bunch of theoretical calculations, Copernicium is predicted to be an extremely noble metal.
Noble metal, like you mean like gold and platinum?
Exactly.
Okay. So is it shiny? Is it valuable? Like what?
Well, it might be.
Yeah.
We can't really say for sure without, observing it directly.
Right, of course.
But here's what's interesting. Copernicium is predicted to be even more noble than gold.
Really?
Its theoretical reduction potential is crazy high,
Okay.
which suggests it would be extremely resistant to reacting with other substances.
So like gold tarnishes eventually, right?
Right.
Would Copernicium just stay pristine, like forever?
It's possible.
That's mind-blowing. Okay, so hold on. Now it gets even wilder, right?
It does.
Because you were saying something before about it maybe having properties similar to like radon.
Yeah, some predictions suggest that.
And radon's a noble gas.
Exactly.
So wait, hold on. We were talking noble metal.
Right.
Now we're talking noble gas. This thing's all over the place.
I know, right?
How can one element be so unpredictable?
Well, you have to remember, Copernicium is a relativistic element.
Okay.
So the electrons orbiting its nucleus are moving so fast that they're actually impacted by Einstein's theory of relativity.
Wait, Einstein? Like the Eames C. A. Tockstein?
The one and only?
What does relativity have to do with an element?
It all comes down to speed. In these really heavy elements like Copernicium,
Yeah.
the electrons are moving at speeds approaching the speed of light.
Wow.
And because of that speed, their mass actually increases.
No way.
Yeah. It's one of the crazy things about elements on the edge of the periodic table.
Okay, I need a minute to process that. Electrons gaining weight because they're speed demons?
Yeah.
That's a whole new level of weird. But how does this relativistic effect make it act like a noble gas?
Right. So think of it this way. Imagine a tiny race car, right? And it's whipping around a track so fast.
Okay, yeah.
That it actually starts to get heavier. That's kind of what's happening.
I like that analogy. I can see it.
To the electrons in Copernicium, they get this relativistic speed boost, and it changes their energy levels and how they interact with other atoms, which can lead to some unexpected chemical properties.
So it's like they're breaking the rules of chemistry because they're on this, like, relativistic joyride?
Pretty much.
Okay, I'm with you.
Yeah.
But I'm still not clear how that explains the noble gas thing.
Okay. So this is still being researched.
Yeah.
But one idea is that these relativistic effects could be making Copernicium's outermost electron shell more tightly bound to the nucleus.
Right.
And if that happens, it would make it less likely to want to interact with other atoms, similar to how noble gases act. You know, they don't really want to react with much.
So Copernicium's electrons are like holding on for dear life.
Kind of, yeah.
As they're zipping around the nucleus, making the whole atom less reactive.
That's a good way to think about it.
That is wild.
It really is. It's like a whole frontier of chemistry, and there's so much we still don't know.
Yeah.
But, you know, the fact that we're even seeing these relativistic effects is incredibly exciting. It opens up so many possibilities for understanding and maybe even manipulating matter in ways we never thought possible.
You know, it's easy to get lost in the weeds talking about electrons and relativity.
Right.
But I think it's cool to, like, step back for a second.
Yeah.
And remember that we're talking about an element that humans made. Like,
that's right.
It doesn't exist naturally, right?
It doesn't.
We're witnessing, like, the birth of a new piece of the universe,
yeah.
essentially.
I love that. Yeah, it's a testament to human ingenuity, our curiosity.
Absolutely.
It challenges what we think is possible.
Yeah.
Pushes the boundaries of science.
So speaking of pushing boundaries, you mentioned something earlier called the island of stability.
Oh, yeah.
And I want to get back to that.
Sure.
What exactly is this island, and what does it have to do with Copernicium?
So imagine you have a map of all the elements, right?
Okay.
Most of them are on stable ground.
Okay, yeah.
But then way out in the distance, there's this mysterious island.
Okay.
On this island, you might find super heavy elements like Copernicium,
yeah,
but in forms that are much more stable than we expect.
So instead of, like, vanishing in seconds, they could exist for, I don't know, days, years.
Potentially, yeah.
That's a game changer for scientists who want to study them.
Huge game changer.
So are you saying there's a chance that Copernicium could be on this island?
Some calculations suggest that certain isotopes of Copernicium might be there.
Okay, so it's a real possibility.
It is. It's like a scientific treasure hunt, searching for these stable forms of these super heavy elements.
So if we find a stable isotope of Copernicium, what would that even mean for science? Like, what could we do?
I mean, it would be huge.
Yeah.
It could completely change how we understand nuclear physics, and maybe even change how we think about matter itself. With a stable isotope, we could finally really study Copernicium.
Right.
We could unlock its mysteries.
Yeah.
And who knows, maybe we could even find practical applications for it.
Hold on. Are you saying this super heavy synthetic element could have real-world uses?
It's not impossible. Right now, because it's so short-lived, it's hard to imagine what you could do with it practically.
Yeah.
But if there's a stable form, who knows? It could have properties we can't even dream of right now.
Okay, now you've really got me hooked. So how are scientists searching for this island of stability?
Well, it's not as simple as just smashing more atoms together
and
hoping for the best, right? It takes Careful calculations,
Right.
really precise experiments, and a little bit of luck, honestly.
It sounds like we've got scientists playing a really high-stakes game of atomic billiards,
Yeah, kind of.
trying to make new elements and figure out the universe at the same time.
That's what's so cool about it.
Yeah, it does sound straight out of science fiction.
But it's real, and it's happening right now.
That's amazing.
And who knows what we'll find on the other side of that island of stability.
Okay, my brain is definitely a little overloaded with all this talk of super heavy elements and relativity.
Yeah, it's a lot.
But before we move on,
Sure.
I remember you started to explain something called spin-orbit coupling.
Oh, right.
And then we got sidetracked by the island. Can we go back to that?
Absolutely. So spin-orbit coupling is a little complicated,
Okay.
but the basic idea is that it's the interaction between an electron spin, which is kind of like its own internal angular momentum,
Okay.
and its motion around the nucleus.
So we've got spinning electrons,
Mm-hmm.
and they're zipping around at relativistic speeds.
Right.
It's like a cosmic dance party in there.
It is. It really is. And in heavy elements like Copernicium,
Yeah.
that dance is even more intense
How so?
because the electrons are moving so fast and they're so close to the nucleus,
Okay.
where the electric field is really strong.
So what does this super intense dance do to Copernicium? Does it affect how it acts?
It does. So this strong spin-orbit coupling actually affects the energy levels of Copernicium's electrons.
Okay.
And that can change how it interacts with other atoms. It
Okay.
can affect things like its oxidation states,
Okay.
which is how many electrons it gains or loses in a reaction and
Okay.
how easily it forms bonds.
But wait, I thought we were talking about Copernicium being super noble.
Right.
Doesn't that mean it doesn't really like to make bonds?
It should, but that's where the spin-orbit coupling throws a wrench in things.
Uh-oh.
It could actually make certain reactions more likely to happen
Oh,
than
brother.
we'd expect just based on where it sits on the periodic table.
So Copernicium is like a rule breaker, even for a super heavy synthetic element.
Pretty much.
But how do scientists even study this stuff when Copernicium disappears so quickly?
It's a huge challenge.
Yeah.
But they're coming up with some really clever ways to probe its fleeting existence.
I like what?
So one technique is called gas phase chemistry.
Okay.
Basically, they study individual Copernicium atoms in a gaseous state so they can kind of watch it react with other elements in real time.
So it's like trying to catch a shooting star
It is, yeah.
and analyze what it's made of all at the same time.
It really is. It takes incredible precision, a lot of patience,
Yeah.
and some really creative thinking.
So have they learned anything about how reactive Copernicium actually is?
Well, there have been some really interesting hints.
Oh.
One study suggested that Copernicium might actually form a weak bond with gold,
Wow. Really?
which is pretty surprising, right, considering how noble it's supposed to be.
Hold on. Copernicium and gold bonding.
Yeah.
That's like the ultimate power couple of the periodic table. What would that even look like?
We don't know.
Yeah.
I mean, remember, we're dealing with tiny, tiny amounts of a radioactive element, so it's
Okay.
hard to say for sure what it would look like.
Yeah.
But even just the hint of a bond is a big deal. It tells us that Copernicium is more than just a theoretical curiosity.
Right.
It's a real element
Yeah.
with its own unique properties,
Yeah.
some of which might surprise us.
You know what? I'm realizing that this isn't just about, like, checking a box on the periodic table.
Right.
It's about pushing the limits of what we know, challenging how we think the universe works,
Totally.
and maybe even discovering things that could change our lives.
Absolutely. That's what's so exciting about it.
It's really incredible. Okay, so I feel like we've gone on quite a journey with Copernicium today.
Yeah.
From smashing atoms together to Einstein's relativity
There's been a lot.
to this mysterious island of stability. It's a lot to take in. But before we wrap up, I have one more question. What about the ethics of all this?
Ooh, that's an important one.
Yeah, I mean, we're creating these super heavy elements.
Right.
Is there a point where our quest for knowledge maybe goes too far?
It's a good question, and it's something that scientists think about a lot. As we get deeper into this world of super heavy elements, we have to consider the risks
Yeah.
as well as the benefits of what we're doing. We have to make sure we're being responsible, ethical.
That's a good point. It's not just about what we can do, it's about what we should do. Right.
Exactly.
But maybe that's a conversation for another deep dive.
Definitely. There's always more to explore.
Okay, so we've talked about how they make Copernicium, what they think it's like,
Mhm.
and the work that goes into, like, actually studying this stuff.
Mm-hmm.
But I got to ask, like, what's the point? Is this just for, scientific curiosity?
Right.
Or could there be some real-world reason to be studying something that's this hard to even see?
It's a great question. It's easy to, get excited about the wow factor of these super heavy elements,
Yeah.
but the WHY is really important. And you're right, Copernicium itself, it probably won't have any immediate practical use
Okay.
just because it's so short-lived.
Right.
But trying to understand it, that has impacts that go way beyond just this one element.
Okay, so what of Copernicium? Like, what's the big picture here?
Well, think of it this way. By studying Copernicium and all its super heavy friends,
Yeah.
we're basically pushing our understanding of the universe to its limits.
Okay.
We're figuring out, what holds atoms together at the most basic level.
So it's like we're taking the building blocks of reality
Yeah.
and seeing how much pressure they can take.
Exactly. And sometimes when you push something to its limit,
Yeah.
you discover something completely new.
Right.
So this knowledge we're getting could be important for things like nuclear energy,
Oh, wow.
even astrophysics,
Okay.
like how stars form, how elements are created in supernova explosions.
Wow, that's the big stuff.
It is. It is.
Okay, so I see how it connects to the really big picture.
Mm-hmm.
But what about stuff here on Earth? Could Copernicium itself, or even just the stuff we learned from studying it, could that lead to new technologies?
It's possible. Think about it. The tools and the techniques that scientists have to invent to study these super heavy elements,
Yeah.
they're cutting edge. And those advancements, those often end up being useful in other areas of science and technology.
So trying to understand something as, I don't know, esoteric as Copernicium
Right?
could lead to improvements in medicine or materials, even computing maybe.
Absolutely. It's like a rising tide lifts all boats. Plus, you never know.
Yeah.
Maybe someday, if we find that stable isotope of Copernicium,
Right.
it could have properties that would just blow our minds.
A stable Copernicium. It's kind of hard to even imagine. What would that be like? Would it be some kind of super material for building spacecraft? A catalyst for some reaction we haven't even thought of yet?
Those are amazing questions.
Yeah.
And to be honest, we're totally in the realm of speculation here, but
Yeah.
that's part of the fun of it, isn't it?
Oh, absolutely.
We're at the edge of the map, looking out into the unknown. And Copernicium, it represents that perfectly.
It's been quite a deep dive for sure.
It has.
We've gone from atom smashing to Einstein to, a hypothetical island of stability.
Yeah, it's been a journey.
It really has. And I think it's given everyone listening a lot to think about. I mean, what I find really amazing is that something so, I don't know, so niche, like studying a super heavy element,
Right.
can connect to such huge questions
Okay.
about what is reality,
Mm.
and the potential for technology that we haven't even dreamed of yet.
Absolutely. It all comes back to that human curiosity and, the pursuit of knowledge.
Yeah.
Even in the strangest corners of the periodic table,
Yeah.
it can teach us so much about the world around us.
So to everyone listening, if you're looking up at the stars tonight, just remember that those same forces that made Copernicium, they're out there shaping the universe. And who knows, maybe someday we'll unlock all the secrets of this element
Yeah.
and even learn to use it to benefit humanity.
That would be amazing. It's a journey worth taking.
It is.
One atom at a time. Thanks for diving deep with us.
Absolutely. Until next time, keep exploring.